Hello students, this is Mr. Hughes coming at you for 17.6 angles in polygons. Angles in polygons. Our objective today is to learn to find the measures of angles in polygons. So basically, if we're given, we want to find the angles of polygons, we can start by tearing off the corners of a triangle and put them together. You'll find that they form a straight angle. This suggests that the sum of the measures of the angles in a triangle is 180 degrees. So if I take all three angles of a triangle and add them together, they are going to equal 180 degrees. The sum of the measures of each triangle, 1, 2, and 3, equals 180. So knowing that, I can find the measure of all the unknown angles. If I know that this angle 55 plus this angle 80 plus this angle x is equal to 180, all I have to do is do a mathematical situation where I take the 80 plus 55 plus x equals 180. Well, we know that in our previous lessons a few weeks ago that we want to get x on a side by itself, so we can just subtract or combine our like terms first, and then we can subtract 135 from both sides to get x equals 45. So in other words, what we're doing is we're taking 180, we're subtracting 55, and we're subtracting 80 to get x, or our last angle there, to equal 55, or 45, sorry. So the measure of the unknown angle is 45 degrees. Here we can find the measure of the unknown angle, and we have two angles, one at 90 and one at 30, and we want to find x. So again, we know that all three of these have to equal 180. So 90 plus 30 plus x equals 180. We can combine those like terms, so 90 plus 30 equals 120. Again, we want to get x by itself. Because it's an addition problem, we're going to subtract 120 from each side. And 180 minus 120 is 60 degrees. So we know that our missing angle x is 60 degrees. All right, on your notes again, we're going to continue to do this. We're going to define the angles of a quadrilateral. So the quadrilateral, again, is a four-sided figure. Quad means four. It also happens to have four angles to it. And the sum is the definition of angles of quadrilaterals. The sum of these measures of the angles in a quadrilateral is 360 degrees. If you take a look at this, and if we were to draw a line from this corner all the way across here to this corner, we could cut this quadrilateral into two triangles. Well, if we know that one triangle is 180 degrees and we know the other triangle is 180 degrees, that makes 360 degrees. So our quadrilateral is equal to 360. So angle 1, 2, 3, and 4 equals 360. So if we need to find the angle measure of our quadrilaterals, we are going to simply take the 360 degrees, and we're going to add up the 65, the 89, and the 82, and the unknown angle of x. We're going to combine our like terms just like we did before. So 65 plus 89 plus 82 equals 236. Because it's an adding problem, we need to subtract both sides by 236. And we're going to get x to equal 124. Now that should completely make sense to you if you look at this angle. This is an obtuse angle, so therefore it's over 90 degrees. So when our measure of 120 happens to be over 90, that should make sense.
All right, it's Mrs. P back in here. Thank you, Mr. Hughes, for that wonderful definitions of areas of triangles and quadrilaterals. Let's check out another one. Find the unknown angle measure in this quadrilateral, and just like Mr. Hughes explained, here we have, we can split this into two triangles, so each triangle is 180 for a total of 360 degrees. So if we add up the three angles that we know, so 67 plus 92 plus 89 plus x, the unknown angle, that is going to equal our 360 degrees. We can combine like terms and get 248 plus x equals 360, and we know, okay, we want to get x all by itself on one side, so we're going to subtract 248 from both sides, and we get that the measure of the unknown angle is 112 degrees. All right, now we're going to draw some triangles to find the sum of the interior angles. So here we have a polygon, and we are going to cut it into triangles to find out how many degrees total, right, is the angles here. We know that in a triangle it's 180 degrees. In a quadrilateral it's 360 degrees. But what if I have a hexagon or an octagon or a decagon? How many degrees are in that shape? And we can find this two ways. So we can cut it into triangles, which we're going to show in a second, and then we also have a formula that we're going to look at. So let's start by dividing the polygon into triangles. What you're going to do is you're going to pick a side. So pick any point, I should say, pick a point on the shape, and from that point you are going to connect to all the other sides. So let's take a look at that again. So pick a point, and here we're going to pick up here, and from this point you are going to connect it to all the other points on the shape. Alright, so there you saw how from that one point we connected to all the other sides. You notice that from here to here, there is not a red line. It's because it's already connected. All right, so we don't need to redraw that line, but we're going to connect all the way to the other points. If we count out the number of triangles we just created, 1, 2, 3, 4, 5, 6. So in this octagon, we created 6 triangles. And we know that there's 180 degrees in each triangle, so if we multiply 6 times 180 degrees, we get 1,080 degrees. So in an octagon, when we add up all the angles together, they should equal 1,080 degrees. Now, when you go to take the MCAs here in about, probably beginning of April here, you're going to see a formula that looks like this. This is going to be on your formula sheet. It says S stands for the sum of its angles. And here's the formula to help find these triangle measures here. If we take n, which is the number of sides, and we subtract 2, now we subtract 2, if we look back at our picture, 2 sides are already connected, so we can take that away to account for that already, and then multiply it by 180 degrees. So in an octagon, there are 8 sides, so 8 minus 2 is 6, and then we take 6 times 180. Oh, so 8 minus 2 gave us 6. How many triangles did we make? 6. So it makes sense. And then we know that a triangle is 180 degrees. All right, let's try it again here. Here now we have a hexagon, so 6 sides. Pick any point, doesn't matter where you begin. And from that point, go ahead and make a line connecting it to another point. So you see all that. You notice that there are 2 sides here already that are already connected. So we make 4 triangles, and each triangle is 180 degrees. So 4 times 180 gives you 720 degrees. So the sum of all the angle measures of a hexagon is 720 degrees. How does that make sense in our formula here? All right, so the number of sides on our shape, it's a hexagon, so there's 6 sides, minus 2. Oh, that gave us our 4 triangles. Every triangle has 180 degrees. If we multiply them together, we get 720 degrees. Alright, so on your homework now, 17.6, make sure that you are reading the directions, make sure you are showing your work on how you got that, and for example 3, make sure you are drawing your triangles to make those lines to multiply them by 180. Alright, good luck.